Good afternoon, my YouTube viewers. In this particular video, what we're going to be discussing is probability theory. So basically, what we're going to do is we're going to go through a program written in Python that covers probability theory. And so before we create the program, the first thing that we have to do is we have to import some libraries. So the first library that we're going to import is random, and this is an inbuilt library in Python, and it will generate random numbers. And then from collections, we're going to import counter. And so collections is a library that allows you to count things, and counter is the function that's actually going to count things. So on number one of this program, we're going to define the sample space for rolling two dice. So sample space equals square brackets, brackets I comma j, brackets for I in range, brackets 1 comma 7, brackets for j in range 1 comma 7. And then it says you're going to, the sample space size. So I think it's going to be 36. I think that that's going to be the sample space for two rolling dice, because one dice is 6 and then two dice is 36, because it's going to be 6 times 6. And then number two, we're going to define the random variable, the sum of the two dice. So sums equals sum brackets pair for pair in sample space. So pair is the two dice. And then number three, we're going to calculate the probabilities for each probable sum. So sum counts equals counter sums. So that's to count the occurrences of each sum. And total outcomes equals len sample space. So I think that's 36. And probabilities equals outcome is count divided by total outcomes for outcome, comma, count in sum counts items. So then we're going to print the probability of each sum for outcome, comma, probability and probabilities dot items, print sum, outcome, and probability. And so we're going to, number four, we're going to demonstrate independence rolling one die versus another die. So die 1 prob equals 1 divided by 6. Die 2 prob equals 1 divided by 6. Joint prob equals sum counts die 1 outcome plus die 2 outcome divided by total outcomes. And total outcomes, I think, is going to be 36. And then return the absolute value of joint prob minus brackets die 1 prob plus die 2 prob is less than i.e. to the negative pi. So that's a small threshold for a floating point comparison. And then you print demonstrating independence. You print are the dice rolled independent, and then you print the result is independent. So you simulate rolling dice 1,000, rolling two dice 1,000 times and estimate probabilities. So simulation equals 1,000, simulated outcomes equals random.randint brackets 1 comma 6 brackets random.randint brackets 1 comma 6 for underscore in range simulations. Simulated sums equals sum pair for pair in simulated outcomes. Simulated counts equals counter simulated sums. Simulated probabilities equals outcome count divided by simulations for outcome count in simulated counts dot items. And then you print simulated probabilities for each sum in 1,000 rows. For outcome probability in simulated probabilities. Dot items, print sum and probability. So number 6, we have conditional probability. Example, P sum equals 7, first die equals 3, condition equals square brackets, pair for pair in sample space if pair 0 is equal to 3. So subset where the first die is 3. And conditional favorable equals square brackets, pair for pair in condition if some pair is equal to 7. And conditional probability equals ln conditional favorable divided by ln condition. So you're going to print conditional probability, and you're going to print the sum equals 7 and first die equals 3, conditional probability. So this is the outcome of the program that we just gone over. I'm just trying to get it. So it's a little bit hard for me to get it. It's being really awkward. It's being really awkward. So the sample space is 36, because that 6 times 6 is 36. And it says probabilities of each sum. So it tells you what this probability of a sum of 2 is, a sum of 3, sum of 4, sum of 5, goes all the way down to 12 or up to 12. And then it says demonstrating independence. Are the dice rolls independent? And it's true. And it's simulated probabilities for each sum 1,000 rows. So sum 7 is the highest probability and going all the way down to sum 2. And it says conditional probability is sum equals 7, first die equals 3 is 16% or 16.67%. So those are the answers to the questions that we had on this question on probabilities. And so that concludes this video, and I hope that you liked it. The next video we'll be talking about some more statistical subjects, and I hope you decide to watch it.